Well, here, because maybe what he said was true, but you interpreted what he said or wrote down what he said incorrectly. So maybe we'll clarify some of that right now. The biggest thing in terms of takeaways for me is notation. And we are on, and this is good for this to happen now, or us to start talking about like notation and how you're communicating your mathematics now, because we have all year to work on this. Like, are you taking what I'm saying?
No, I was just scrolling to the math quiz. I have it.
Cool. So yeah, number one, fine, pretty straightforward. G, I'm going to let you guys kind of figure that out. And then you were evaluating limits analytically. So we come to this piecewise. Now, notice that the question is asking for the limit as x approaches 3 of f of x. F of x is this entire piecewise, not just this rational function part. That's not even a rational function. Not even just this part. Like, the piecewise is this entire function. Now I realize that f of x will look like this function everywhere except for at one single point. But each of these pieces together represents the function f of x. Like, this rule is not f of x by itself. It's together, they represent f of x. And you're being asked for the limit as x approaches 3 of f of x. Okay, so if you were to use direct substitution here, but I know that you guys were like, this is a piecewise, I probably shouldn't use direct substitution, because direct substitution would just result in 2, right? It's a piecewise, and everywhere except for at x equals to 2, the graph looks like this. So, and I'll write it on here. Maybe I'll put an extra page to show this. So what I showed the classes last week, and I think was helpful before we kind of dove into this particular piecewise, is like if I give you a different piecewise, like let's say we think about having like g of x equals to x squared for all real numbers except when x is equal to 1. And then whenever x is equal to 1, g of x will be equal to like 10. And if we were to think about this piecewise, the graph of this piecewise, which has similar behavior to the graph of f of x, but like the rules of each piece are a little bit, at least that first piece is less complicated. So like this graph would look like x squared everywhere except for x equals to 1. And then whenever x is equal to 1, the y value is 10. So like we would say the limit for this function, the limit as x approaches 1 of g of x, we would say that that's equal to what? 1. And it would be the same thing as thinking about the limit as x approaches 1. Oops. Where's my reverse? There we go. Of x squared, right? And then thinking about using direct substitution there. Because the graph looks like this rule everywhere except for at this single point. But for a limit, we don't care what's happening at the x value. We care what it seems like the function is trending towards. Do you guys understand, kind of follow where I'm going with this? So then when we go back up to this piecewise, and you're trying to determine the limit as x approaches 3 of f of x, right? The limit as x approaches 3 of f of x. And you're like, piecewise. So then, everywhere except for at x equals to 3, the graph looks like this. Here's the thing. If you were to use direct substitution into this rule, what happens?
You get something equals 0.
What's the something? Wouldn't it be 0 over 0? And then you're like, 0 over 0, this kind of looks like Jumpman. We see that? So then you might think, oh, well, this is kind of a Jumpman situation. So I'm going to think about the one-sided limit. So the limit as x approaches 3 from the left. The most common thing that I saw was people showing the left-sided limit, which is wonderful. Like, I know they were considering this one-sided limit, but instead of writing this, they went directly to saying this, which is meaningless. When you're actually finding this limit, right? It's not referencing the correct function. You have to reference the limit of f of x, and then you can recognize that this limit ends up being equal to this limit, but otherwise you've kind of broken the chain of communication, like your thought process for determining this limit if you stop referencing f of x. So then from here, and you could have also like done some algebra already. So if you're like, oh, the limit as x approaches 3 from the left, you know this results in 0 over 0. So then you factor, right? It was x plus 1.
To be fair though, I did this before I watched the notes.
Oops.
For this lesson. If that's any consolation.
Okay. So then if you're thinking about, I don't know why this moved for me. How do I move this back up here? You guys can't even see it, can you? How do I move this? There we go. Okay, sorry. So then if we think about the limit as x approaches 3 from the left, for Jumpman, wouldn't that be -1? And then using direct substitution into the x plus 1, well, 3 plus 1 would be 4. So this limit is -4.
Wait, Ms. Dorsey, it's always negative when it approaches from the left, right? -1.
Well, if you're thinking about like Jumpman as the parent function, then yes. But if there had been some sort of like reflection, then that wouldn't necessarily be the case. So you're thinking about Jumpman as being like x over absolute value of x as being the parent function.
Oh, yeah.
And then the limit as x approaches 3 from the right.
Probably the same, right?
And you can think about using the factored form if you're comfortable. Oops, I almost made the same mistake as you guys.
So we should get the points back.
No. You have to reference f of x, and then thinking about the limit as x approaches 3 from the right of x minus 3 times x plus 1 over absolute value of x minus 3. From the right, Jumpman's going to be 1 times 4, which would be 4. Now here's the next part. You had to, if a limit was D and E, you had to justify why. So you could say like, since the limit as x approaches 3 from the left of f of x, I don't care about the limit of this. Like if you made the statement, this is not equal to this, you haven't referenced the correct function. So the limit as x approaches 3 from the left of f of x is not equal to the limit as x approaches 3 from the right of f of x. Therefore, the limit as x approaches 3 of f of x. Some of you guys didn't even make this statement. You kept going with just the x squared minus 2x minus 3 over absolute value of x minus 3. That's not the limit that you were being asked for. It might match that limit, but the limit is for f of x. But that limit is d and e.
You do not let Tony help you forward.
So the idea is pay attention to like those details of like function names. Don't introduce new notation. Like don't introduce a new function name. Don't change the capitalization of the function name. Don't change the capitalization or the variable of the independent variable. Like go with what's given. The other one that I wanted to mention was this one. Okay. And maybe this was I'm figuring this was maybe a group that worked together or checked in with each other, but a number of people forgot to say something about that inequality that was given. And you have to remember you're thinking, okay, limit as x approaches -1 of f of x. Well, I don't even know what f of x is, but your spidey sense should be like, squeeze theorem, because you're given this inequality, right? That relationship between those three functions on the interval from -2 to 0. So you should say something about, I always say, since f of x is greater than or equal to g of x and less than or equal to h of x. I did not take anything off for this because I took off if you didn't make this statement, but really you should be saying for x between -2 and 0. I didn't take anything off, but like that relationship is only true on that interval. So you should be including that interval like it's part of that statement. And this is, I don't know if I've said it to this class, but like these are details that like you really do want to pay attention to. When you take the AP exam, the free response questions, every bit of information that is given to you matters and is important for the question. And you need to be thinking, okay, well, why is this given piece of information important? And like making sure that like if you're using something as a precondition, like this piece of information, the fact that f of x is greater than or equal to g of x and less than or equal to h of x, the for x between -2 and 0 is part of this statement. Without it, like you haven't made the complete statement. That indicates that one of the conditions for squeeze theorem to apply is present. Okay, and then from there are different ways to show this. Like the way that I showed you was just thinking about taking the limit as x approaches -1 of those outside functions. So you can reference here, it's okay to reference g of x, or if you could reference just the rule, that's okay too. Because g of x is this. It's not a piecewise, it's not like you're only referencing part of g of x. Like you can reference as g of x, or you can reference sine of pi over 2, blah, 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 blah. Okay, so then the limit as x approaches with -1 for g of x ends up being 4. And the limit as x approaches -1 of h of x ends up also being 4. So you can say, therefore, by the squeeze theorem, the limit as x approaches -1, and yes, you need to mention squeeze theorem, of f of x would also be equal to 4. Now, some textbooks, and some people used to this, prefer to just go off of doing the second condition of the limits of the outside functions, like to use the inequality and go, oh, the limit as x approaches -1 of g of x is less than or equal to the limit like think about taking the limit of each part of the inequality, and that's fine. Right? And then you go, oh, that's 4. And then you can really see why the limit of f of x ends up also having to be 4. Right? So you could make the statement like that in order to make this conclusion that by the squeeze theorem, the limit as x approaches -1 of f of x is also equal to 4. So this is the same, this is communicating the same information as these two limits, showing that you've considered these two limits. Questions on that?
I'm
Not wrong. I made the same mistake, just on my own.
Did you forget to say
It's
the inequality?
One time I skip a lesson,
I
and it's on
also
formatting like this. You're not off it, huh?
Because I thought it was stated in the sentence.
It's not. So so that brings us a really important. So squeeze theorem is a way of analytically evaluating a limit, right? Whenever you can't use algebra, you can't use calculus. Like it's a way of evaluating a limit analytically. In order to apply squeeze theorem, though, you have to state the conditions for squeeze theorem to apply. And that's why you have to restate that. This question didn't tell you to use squeeze theorem, right? It's giving you information in order to evaluate this limit, and you're having to pull that information out and being like, oh, squeeze theorem can be applied here because this is true, and therefore, by the squeeze theorem, this limit is true. This is going to come up over and over and over again, especially with these like existence theorems, like intermediate value theorem, which you will have questions on. Like you can almost guarantee you will at least have an intermediate value theorem or a mean value theorem question where you're having to make these statements about the conditions for the theorem to apply and be true. So this is just an example or kind of intro to that where you're having to think, okay, this condition applies, and then I can apply this theorem. Those are my biggest takeaways. It's mostly like notation.